So the next couple of lessons, we're going to be looking a bit at probability. Okay. Now, there's two types of probability, really. There's those that are sort of theoretical. So if you go and flip a unbiased coin, you know it's 50-50 that it comes down heads or tails. Okay, so you know if it's a fair coin and you flip it 100 times, you would expect to get about 50 heads and about 50 tails. It probably won't be exactly that, but it will be roughly that. If you went and got 90 heads and 10 tails, you're going to start thinking that the coin might be a bit biased. Okay, same if you roll a dice. You know if it's a fair dice, you've got a 1 in 6 chance of getting any of the numbers. So if you were to roll it 600 times, you would expect to get about 100 ones, 100 twos, 100 threes, 100 fours, 100 fives, 100 sixes. So that's what we're going to move on to tomorrow. That's when we're going to be looking at expected probabilities. So that's the one at the bottom. So an example of that is an expected probability example. I roll a fair dice 600 times. How many times would I expect to get a 6, for example? Okay, and the answer would be 100. So that's what we'll be moving on to tomorrow. That is a theoretical idea. Okay, now quite often in the real world, there's no real theory to it. Now, if you went outside and just sat down by a road and you would say you were trying to work out the probability that the next car that went by was red, it's just, you don't know that. You just don't know theoretically how many times a red car would go by. You might think in your mind, well, red cars are more common than black and white striped cars, or they're more common than gold cars, but you don't really know. So where you have something like that, where you can't know in advance, the only way you could work that out is to start off by getting some data. You might sit down and go and make a note of the first 1,000 cars that come by, how many of them were red. Okay, now say you did that, say you just went into the little sort of tally chart and there's a red car, there's a blue car, there's a white car, there's a green car, and you went and did that for 1,000 cars. Say you went and found out that 200 of them were red. So 200 of them out of 1,000 were red. Well, that's 200 over 1,000, which is a fifth. You could then use that information to kind of predict, if you went and did it another day, how many red cars would go by. Okay, so when we're doing this, this is more of a practical idea. Okay, you can these probabilities, you need to have a set of data. Somebody needs to have gone out and sat by the road and created a table of data to enable you to use that to try and judge, to try and estimate what will happen in the future. So this is called a relative frequency. Okay, relative frequencies. So an example of this is how many red cars would I expect to pass my house? Something like that. Okay, and you can only do that if somebody's gone and done some work beforehand and created a table of data. Okay, now these are ever so straightforward. So the key bit here was really just understanding what this is all about. So I've just done a couple of examples here. Okay, so this isn't a fair dice, this is a biased dice. Okay, so obviously if it was a fair dice, I would know what to expect. But this dice is rolled 24 times, and those are what I got. Twice I got a 1, 3 times I got a 2, 8 times I got a 3. So it looks like this dice might come down on 3 more often than not. So what is the relative frequency? Now I just want you to get used to the dice. When it says relative frequency, this is a probability. This is a probability. So you've just got to work it out like you would normally do a probability. You need to have the total number on the bottom. So if a dice is rolled 24 times, I'm going to be taking it out of 24. And what is the probability I land on a 5? Well, I've got 3 5s. So it would simply be 3 over 24, which of course, if you wanted to, you could simplify down to 1 over 8. So it is literally as simple as that. Relative frequency is a probability. So you've just got to divide the frequency of what you want to happen. So that could be that 200 red cars going by my house, divided by the total number. So that would be the total number of cars going by my house. So this would be that 200 over 1,000 I was talking about a bit earlier on. So another example, slightly more complicated, but not that difficult. An arrow on a spinner is spun 240 times. Some of the results are shown below. The relative frequency, so the probability of landing on a 4 is the same as landing on a 5. So those two are the same. Work out the relative frequency of landing on a 4. So I would go and add up my 25 and my 53 and my 62. I get my calculator out and add those up. 25, add 53 and 62, and that is 140. Now, it was spun 240 times in total. 140 of them are 1, 2 and 3. So 240 take away 140 is 100. So I've got to spread 100 between the 4 and the 5, and I'm told that they're the same. So obviously 100 divided by 2 is 50. So to give my answer, which is relative frequency, remember that is a probability. So the chances of me landing on a 4, well, is 50 out of that total of 240. Okay, and that would be your final answer. If they wanted it simplified down, you can divide top and bottom by 10, which would be 5 over 24. And that's it, folks. Okay, so I'm just going to stop this recording, and then as per normal, I would like you to crack through the questions that I've set on Dr. Frost. And I don't think you'll need any help. I expect you'll rattle through these in no time. But and then as normal, I will keep an eye on how you're progressing as I've got all my answers up, or as I've got the Dr. Frost analysis over on a separate laptop. So stop recording. So I've